Good morning viewers. The course name for this presentation is Power Generation Technologies and the topic will be covered is Steam Power Plant. I am Dr. Suraj Kumar Mukti, Associate Professor in the Department of Mechanical Engineering, National Institute of Technology, Raipur. I would like to welcome here in this platform, that is SWAM platform. The content of the presentation will be the steam power plant introduction. Then we will go for steam power plant components, various components used in steam power plant will be discussed here. Energy conversion, what are the concept of energy conversion, we will discuss here one by one. And we will go for sources of energy, various types of sources are energy available, we will discuss in detail in this section. Then we will go for fuels and their classification, and we will enter into the power plant. Various types of power plants will be discussed here in this segment, and we will enter into the thermal power plant, what is called as thermal power plant and what are the basic components of thermal power plant will be discussed here. Steam power plant site selection, on what basis the sites for steam power plant is selected, we will discuss here one by one. Steam power plant layout, on what basis the layout is selected, we will discuss here. Then we will go for steam power plant equipments, various types of equipments and components are there, it will be discussed in detail here. Then we will go for circuits, various types of circuits will be useful for steam power plant, that will be discussed here. Then at last portion we will enter into the steam power plant advantages and disadvantages. These advantages and disadvantages will be discussed here in broader way. As we can say introduction, the power generation technology or engineering is a science which deals with the complete study of different types of power plants. Power plant engineering is a branch of a field of energy engineering, and it is defined as the engineering and technology required for the production of an electric power. This field is a discipline using the theoretical basis of mechanical engineering and electrical engineering. Here in this slide we can see a broader view of a power generation plant. Now we will enter into the definition part, what is called a steam power plant. A steam power plant, also known as a steam power station, is a facility designed to generate electricity through the use of steam as the primary working fluid. It operates based on a principle of thermodynamics, utilizing the conversion of heat energy into mechanical work and subsequently into electrical energy. The primary components of a steam power plant include number 1 boiler, a turbine, a condenser and a generator. Now we will discuss about the components of a steam power plant. First is boiler, then turbine, then generator, then we will go for condenser, and last one is cooling system. For what purpose the boiler is used? The boiler is used to generate heat. It is achieved by burning fossil fuels like what are fossil fuels? Fossil fuels are coal, oil or natural gases, or by using nuclear energy. Generated steam is at high pressure and temperature. Now we will enter into the turbine. What is turbine? Turbine is a work generating component. As the steam flows through the turbine, its high pressure energy is converted into rotational mechanical energy. Now about the generator, what is the definition, what is the function of generator? Generator is electricity generating component. As the turbine spins, it turns the rotor of the generator, creating moving magnetic field. The moment includes electric current, ultimately producing electrical energy. Now enter into condenser. Condenser is a condensing device which condenses the steam. The steam is cooled and condensed back into the water, releasing its latent heat. This process allows for the efficiency reuse of the water in the boiler, reducing water consumption and increasing overall efficiency. Then about the cooling tower. Cooling tower is a cooling component, dissipates excess heat from the condenser, cooling water from nearby water bodies, cooling tower or other heat exchange methods. Here we can discuss more about the components. This figure shows the basic component arrangement of the steam power plant. Initially we have a boiler, then turbine, then condenser and then pump. So, these are the 4 basic components of any steam power plant, and fifth one is called as cooling tower, which is shown in the side of the condenser. Energy conversion concept. When we talk about the concept of energy conversion, then we can talk about various kinds of energies like chemical energy, mechanical energy, heat energy, sound energy, etc. A critical property of energy is its ability to change from one form to another. For example, chemical energy from fossil fuel, coal, oil and natural gas can be converted into heat energy when burned. The heat energy may be converted into kinetic energy in a steam turbine and finally into electrical energy by a generator. The electric energy may subsequently be converted into light, sound or kinetic energy in our homes through various household appliances. The transformation of energy is shown here in this picture. In this picture, we can see a thermal power plant which is situated in a particular place, and using this thermal power plant we are able to produce electricity, and that electricity will be used for our household applications as well as industrial applications. Now, here in this picture we can see the energy transformation, how various energies are transformed into another form. Here in first picture we can see chemical energy of a fruit is converted into motion. Once we are having this apple, once we are having our food, the chemical energy of that food we are getting, and that chemical energy is being used for any kind of motion by a human being. So, here we can see in this picture the chemical energy is converted into the motion, and in next picture we can see the chemical energy is converted in motion again, like we are using the petroleum products like petrol, diesel and other CNG gases, etc. So, these are the chemical energy, and these chemical energies are converted into motion using various kinds of vehicles, that may be a car, that may be a moped, etc. Now, in next picture we can see radiant energy is converted into chemical energy. Radiant energy which we are getting from sun is being converted into chemical energy using photosynthesis process by our plant, by the tree. In last picture we can see electrical energy is converted into thermal energy. So, thermal energy can be used for cooking of various food products, cooking of other products also. Here we will discuss about the sources of energy. So, basically the sources of energy can be divided into 2 broad categories. Number 1 is non-conventional sources and number 2 is conventional sources. What is the meaning of non-conventional sources and conventional sources? Here we will discuss in broader way. So, the non-conventional sources are known as renewable sources also, because it can be renewed, and whereas the conventional sources are non-renewable sources. I will give the example of non-conventional sources or renewable sources. These can be shown as solar energy, wind energy, tidal energy or water energy, which is shown here in this slide. So, here these are called as renewable energy. Why this is called as renewable energy? Because this can be renewed. So, it is called as renewable energy. Whereas, in other hand we can call the conventional sources of energy or non-renewable energy, which cannot be renewed. So, it is called as non-renewable energy. It consists coal, diesel, nuclear activity and materials, etc. So, here in this slide we are able to see the broader classification of sources of energy, conventional sources and non-conventional sources. When I say conventional sources, it means it can be again subclassified in commercial conventional sources and non-commercial conventional sources. So, here we can consider the coal, petroleum and electricity as a commercial conventional sources, and firewood, straw and dried dungs etc. can be considered as non-commercial conventional sources. Non-conventional resources can be further classified as bioengineering, solar engineering, wind engineering, tidal engineering, energy from urban waste etc. Sources of energy, here we discuss about the conventional sources. As we are aware about the conventional sources, oil, natural gases and coal, these are called as conventional sources. Energy that has been used since ancient times is known as conventional energy sources. Coal, natural gas, oil and firewood are example of conventional energy sources. Conventional sources of energy are the one of the commonly used and generally non-renewable source of energy, which have been used for a long time. In other words, when we cannot reuse the above source of energy after using it once, we cannot use them again. So, this is called as conventional energy sources. Source of energy, non-conventional energy. So, which is called as non-conventional source of energy? Natural resources like wind, tidal, solar, biomass etc. are called as non-conventional energy sources. These are pollution free and hence we can use these to produce a clean form of energy without any wastage. This figure shows the picture of non-conventional sources of energy. Now, we will discuss about the conventional energy. What is conventional energy? Solar energy, wind energy, hydroelectric energy, tidal energy, ocean wave energy, ocean thermal energy, heat pump from deep under the ground, biomass energy, biofuel energy and biogases are called as conventional energy sources. Now, how these fuels can be classified? We will discuss about this. The fuel can be classified in two broad senses. Number one is primary fuel and number two is called as secondary fuel. What is called as primary fuel? Primary fuel occurs in nature, whereas secondary fuel, it is prepared by primary fuel only. Various types of fuels are there, and here we can see in this chart the types of fuels like solid fuel, natural, wood, peat, lignite coal, and this is prepared from this wood is called as coke, and peat, charcoal, and lignite coal, briquettes. Using liquid as a fuel, primary fuel, then petroleum is the natural primary fuel, and using this petroleum we can prepare secondary fuel like gasoline, kerosene, fuel oil, alcohol, benzol, shale oil etc. Gaseous, natural gases, we are having natural gases which is the primary fuel source, and using these natural gases we can produce secondary fuel like petroleum gas, producer gas, coal gas, coke oven gas and blast furnace gas etc. Now, we will discuss about the types of power plant. Various types of power plants. What is called as power plant? Let us see first. A power plant or power generating plant may be used or may be defined as a machine or assembly of equipment that generates and delivers a flow of mechanical or electrical energy. The main equipment for the generation of electric power is a generator. When coupling it, a prime mover runs to the generator, the electricity is generated. There are several types of power plants mainly depending on the types of fuel used and types of prime mover used. For the purpose of bulk power generation, only for major types of power plants which are as follows: number 1 thermal power plant or steam power plant, number 2 nuclear power plant, number 3 hydroelectric power plant, number 4 diesel power plant. A thermal power station is the most convenient method of generating electric power with reasonably high efficiency. It uses coal as the primary fuel of boil the water available to superheated steam or running the steam turbine. In India, 65% of total power is generated by the thermal power station. Generally, in India, bituminous coal or brown coal are used as fuel of boiler which has violet content ranging from 8 to 33% and as content of 5 to 16%. To enhance the thermal efficiency of the plant, the coal is used in the boiler in its pulverization form. In other words, the thermal power plant is a kind of power generation plant where we convert the chemical energy of fossil fuel like coal, oil, gas, thermal energy into the electric power. Around the world, we use steam turbine to rotate, generator and generate electricity. Such a type of plant is known as steam power plant. A steam power plant continuously converts heat, energy released by burning of fuel into work in which a working fluid, that is water, repeatedly perform a succession processes. The turbine in the power plant requires large quantity of steam which is produced is steam generator or boiler at high pressure. A thermal power station is a power plant in which the prime mover is steam driven. Water is heated, turns into steam and rotates a steam turbine which drives an electric generator. After it passes through the turbine, the steam is condensed in a condenser and recycled to where it was heated, that is known as Rankine cycle. The greatest variation in the design of thermal power station is due to the different fuel sources. Some refer to use of the term energy center because such facilities convert from heat energy to electricity. A large proportion of carbon dioxide is produced by the world's fossil fired thermal power plant. Efforts to reduce this outlet as various and widespread. Here in this slide, we can see the functional diagram of a thermal power plant where we can see the various components clearly in this picture. This picture also shows a clear cut picture of thermal power plant. In this picture, we are able to see various components of a thermal power plant. Now, the question arises on what basis the site can be selected for a thermal power plant. Now, here we can see the factors on which the thermal power plant site selection should be there. Number one, we can consider as availability of raw material. So, once the raw material is available in nearby, the site can be selected for the steam power plant. Next, going to the nature of land and its cost. So, on the basis of nature of land and its cost, we will select the site for steam power plant. And the next one is availability of water, because water plays a very important role during the production of electricity or during the production of energy in steam power plant. So, easily availability of water should be there. Next factor is load center. Next factor will be considered as transport facility. So, transport facilities should be easy, of course. Availability of labor. So, easily available labor should be there, because mostly the plant will be dependent on the availability of labors only. Ash disposal facilities should be there nearby the site, and future expansion of the plant should be there. So, the scope of the future expansion should be there. Pollution is another very important component. So, pollution should be less. So, the location should be the far away from the people. Distance from the populated area should be much enough so that the people may not be affected directly from the pollution. steam power station must be placed closer to the coal mines to lesser the transportation cost of the fuel. Steam power plant using coal or oil fuel needs a very large amount of fuel per annum. The steam power plant should be placed near to the coal mines so that the transportation cost of fuel is at least the lower. Nature of land or its cost. The chosen site should have a high bearing capacity of least 10 Newton per square millimeter to withstand the dead weight of the plant. The thermal power plant should be located at a place where land is cheap and the further expansion is possible. Availability of water. The station must be positioned near a river bank or canal for constant water supply. The steam power plant utilizes water as working solution throughout the year, which is regularly evaporated and condensed. In order to decrease the transportation cost, the plant should be placed near load center. The location of the factory at the center of the load center, the cost of transmission channel and the losses occurring in it. The transportation must be well attached to important transportation routes, example rail, road, etc. A new steam power plant often needs to transport material and machineries. Therefore, sufficient transportation facility must exist, that is the plant should be well attached other plants or the land by rail or road, etc. Skilled and unskilled labor should be available at reasonable rates and near the site of the plant. Here in this slide we can see the location of plant layout. This picture shows a minute detail of steam power plant. This picture shows a minute detail of steam power plant location. So, from which location, from which component to which component, which type of connection should be there, this picture shows clearly. Now, entering into the components of steam power plant, this picture shows the minute equipment of steam power plant. Coal conveyor. The coal conveyor is a belt type arrangement that is used to move coal efficiently. Pulverizer. Pulverizer increases the coal combustion efficiency of coal. Next one is boiler, that is the furnace. A boiler is a device used to create steam by applying heat energy to water. Superheater. Superheater is used to heat the steam up to superheating range. Economizer. Economizers are the mechanical device intended to reduce energy consumption or to perform another useful function like preheating of fluid, etc. Reheater. Reheater added heat to high pressure steam. Steam turbine. Steam turbine is a mechanical device that extracts thermal energy from pulverized steam and converts into rotary motion. Generator. A generator is a device converts mechanical energy into electrical energy, is called generator. A condenser is a device or unit used to condense or substance from the gaseous to its liquid state, typically by cooling it. Deaerator. Deaerator is a device that is widely used for the removal of air and other disposed gases from the feed water of the steam generator boiler. Piping system. Piping system is necessary to convey steam and water from one section to other section. Now, here we will discuss about the various circuits to be used in steam power plant. So, basically 4 types of circuits are used here. Number 1 is coal and ash circuit. Number 2 is feed water and steam circuit. Number 3 is air and gas circuit. And number 4 is cooling water circuit. Let us see one by one these circuits, what happens in these circuits. Now, here in this slide we can see the circuit of coal and ash portion. Here we can see coal delivery, coal unloading, coal preparation, then we go for coal transfer, then coal storage, in plant handling, boiler furnace, then we enter into the ash handling and ash storage. So, this is a complete coal and ash circuit. Now, here we can see another circuit that is called as water and steam circuit. It consists of a feed pump, economizer, boiler drum, superheater, turbine, condenser, etc. Feed water is pumped to the economizer from the hot water well. This water is prepared by the flue gases in the economizer. This preheated water is then supplied to the boiler drum. Heat is transferred to the water by the burning of coal. Due to this, water is converted into steam. The steam raised in the turbine is passed through a superheater. It is superheated by the flue gases. The superheated steam is then expanded in turbine to do work. The turbine drives a generator to produce electric power. The expanded or exhaust steam is then passed through the condenser. In the condenser, the steam is condensed into water and recirculated. A line diagram of the water and steam circuit is shown separately in the picture. In this picture, we can see a line diagram of water and steam circuit. From here, we can see the feed pump is there. From we pump the water into the economizer, then it enters into boiler, then superheater. In this superheater, the water is in the form of steam only, and this steam is entered into turbine, where we will be able to get work done. Then after turbine, we will condense it using condenser, then condensate pump is used, and ultimately this condensed water is again recirculated to feed pump and economizer, and hence the circuit is going on continuously. We will discuss about air and flue gas circuit. It consists of forced draft fan, air preheater, boiler furnace, superheater, economizer, dust collector, induced fan, chimney, etc. Air is taken from the atmosphere by the action of forced draft fan. It is passed through an air preheater. The air is preheated by the flue gases in the preheater. This preheated air is supplied to the furnace to add the combustion of fuel. Due to the combustion of fuel, hot gases are formed. Here in this circuit, we can see the air and flue gas circuit. So, starting from atmosphere, atmospheric air is taken into the system using FD fan. Air preheater is used before entering into the boiler. Then in this section, in air preheater, air is preheated and fed into the boiler, and after boiler, superheated steam is sent to the economizer, and again from economizer the air is sent to the air preheater. After this air preheater, it is sent to dust collector, and here we use FD fan and the entry of the chimney, and the flue gases are blown away using chimney to the atmosphere. Next circuit is cooling water circuit. The circuit includes pump, condenser, cooling tower, etc. The exhaust steam from the turbine is condensed in a condenser. In the condenser, cold water is circulated to condense the steam into water. The steam is condensed by losing its latent heat to the circulating cold water. In this slide, we can see the cooling water circuit. Here we can see the tower, this is called as cooling tower, which consists of air and water, and condenser is there, and pump we can see in this slide. So, in this slide we can see a complete circle of cooling water circuit. Now, at last portion of this presentation, we can see the advantages and disadvantages of a steam power plant. Here we will discuss about the advantages of a steam power plant. As compared with power generating plant, it has low initial cost and hence economical. Less land area is required for the steam power plant as compared with the hydro power plant. Coal is used as a fuel, and the cost of coal is cheaper than petrol and diesel fuel. So, the power generation cost is economical in case of steam power plant. This power plant has easy maintenance cost. Steam power plant can be installed in any area where water sources and transportation facility are easily available. The unit capacity of thermal power plant is more. The cost of unit decreases with the increase in the unit capacity. Life of the plant is more, that is 25 to 30 years as compared to diesel plant, that is 2 to 5 years. Suitable for varying load conditions. So, here we can say the load condition, varying load condition can be cope up in the steam power plant easily. No harmful radioactive wastes are produced as in case of nuclear power plant. There are no transmission losses since they are located near load centers. Some disadvantages are also encountered during the production of energy using steam power plant. The running cost of steam power plant is comparatively high because of fuel and maintenance of plant. The overall efficiency of steam power plant is less than about 35% to 41%, which is low. Due to the release of burnt gases of coal fuel, it contributes to the global warming to larger extent. The heated water that is thrown in the river, pond puts adverse effect on the living organism of water and disturbs the ecology. Starting up plant and bringing into service takes more time. Cooling water requires is more, here in this case, in the case of steam power plant. Space required is more, storage required for the fuel is more. Ash handling is a big problem in the steam power plant, not economical in area which are remote from the coal fields. Fuel transportation, handling and storage charge are more. So, overall we can say the steam power plant is economical as compared to other power plant. Thank you very much.